Swayam Prabha. Digital India. Educated India.
Namaste and welcome back to the video course on Watershed Management. In module number 10, lecture number 39, today we will discuss about water recycling. So, some of the important topics covered in today's lecture include water recycling uses, benefits, water management solutions, water recycling treatments, primary treatment, secondary treatment, tertiary treatment, conventional and modern techniques. Keywords for today's lecture: water recycling and wastewater treatments. So, as we are discussing in the last lecture, so this water conservation is very important as far as the water management in a watershed basis in a watershed is considered, or in a district or in a city is considered. We have to look, say, which way we can go for water conservation. So, that is one aspect, the conservation is one aspect, and then still we may have lot of water stress or say water scarcity in many areas. So, then especially in urban areas, say where we need a huge amount of water for say domestic, industrial and other purposes, but availability is much less. So, there, say, other than water conservation, I mean by reducing the amount of use of water and the most efficient way utilization. So, that is what as we discussed in the last lecture about the water conservation, but say especially in urban areas we can go for water recycling. So, water recycling is mainly, say, we can give some treatment to the wastewater or the effluent generated from the particular domestic or the industrial or whichever sector we consider, and then say we can use for other purposes. So, that is the in a general way what we can define as water recycling. So, other than water conservation, we have to go for water recycling, so that the water stress or the non availability of water we can sort it out in certain way. So, when we discuss about the water recycling, so as I mentioned, water recycling is reusing treated wastewater for beneficial purposes such as agricultural and landscape, irrigation, industrial processes, toilet flushing and groundwater recharge. So, that way, say for example, if you consider a domestic purpose is concerned, see if this is a residential building, then we can see that the water coming from the sinks, we can separate it and then give some treatment like say preliminary or primary treatment, and then we can directly use for say irrigation like this. And then say for example, the water coming from the toilets also we can do some kinds of through, it can be passed through a septic tank or it can be given some treatment and then directly used for other purposes. So, that way say a common type of recycled water is water that has been reclaimed from say the wastewater or sewage. So, it can be say either from the industrial sources or it can be from the domestic sources or as such the municipal wastewater. So, as we can see that when we look into the hydraulic cycle, actually the nature is also doing the same. So, through the natural water cycle, the earth has recycled and reused the water for say millions or billions of years. So, the water is coming as precipitation and then it goes through the hydraulic cycle and finally it is evaporated and then finally again coming back as rainfall. So, the nature is also doing in one way or another way of natural water recycling, but say as far as the in terms of water recycling here what we are discussing is what way we can say give some treatment and reuse for various purposes, either for agricultural, industrial, domestic or other kinds of purposes. So, that is the in terms of water recycling. So, when we look into water recycling, so we can see that when we critically analyze the water recycling. So, actually it offers the resources as water as a resource, and then that way we can see that lot of financial savings we can obtain through the water recycling. So, the advantage is that the wastewater treatments say we can tailor made to meet the water quality requirements of planned reuse. So, say for example, if we are going to use the wastewater for say irrigation or the agricultural purposes. So, it may we do not have to give for complete treatment, maybe a preliminary or primary treatment or secondary treatment may be sufficient depending upon the quality of the wastewater. So, then say recycled water for landscape irrigation, say for example, requires less treatment than recycled water for say for domestic or drinking purposes. So, if we are planning to use say for example, drinking, then we have to go for entire cycles of treatment like preliminary, primary, secondary and tertiary treatment, and even say reverse osmosis or that kind of treatment is required if you are going to use for drinking. But for other purposes like irrigation or the industrial reuses, that way we do not have to give that much treatment. So, that way we can see that we can save water. So, that way we get the financial savings, and then also we can reduce the amount of wastewater to be treated for various purposes. So, that way when we look into water recycling, so water is sometimes recycled and reused on site. So, that means say in an industrial site, there itself we can simply give some treatments and directly utilize. So, industrial facility recycles water for cooling processes. And then another type of the recycled water is water that can be reclaimed from municipal wastewater or sewage. So, we can see that as far as the municipal wastewater is concerned, the wastewater is collected from various sources, and then it will be totally heterogeneous type of wastewater, and then again that also we can give some treatments and then say reuse. So, that way we can see that grey water is say a reusable wastewater from residential, commercial and industrial bathrooms, sinks, bathtub, shower drains, cloth washing equipment, drains, etc. So, the wastewater we can collect from various sources, and then actually when we deal with the municipal wastewater, it will be a mix of many of these things, and then we have to give appropriate treatments before we reuse for the intended purposes. So, grey water say reused on site, say for example, for landscape irrigation like that. So, that way when we look into water recycling, it depends upon the quality of the wastewater, and then say what grade of treatment we have to give to that wastewater, and then what purpose we are going to use that treated water. So, accordingly say we have to give appropriate treatments, and then appropriate use we have to identify as far as the wastewater is concerned. So, when we look into literature, we can see that the recycled water we can use for different purposes. So, even though with say complete set of treatment starting from primary, secondary to tertiary, and treatment like say ultraviolet or the reverse osmosis type of treatment we can use for potable purposes. But say when we look into literature, we can see that the recycled water is very rarely used for potable purposes, only say in some cases where totally fresh water is not at all available. So, we can see that the recycled water is not generally used for potable purposes, but used for non-potable purposes. So, some of the important non-potable purposes here I have listed like agricultural. So, we can use for irrigation. So, only thing is that if say the particular product we are directly using for the consumption, human consumption, or the say raw vegetables like that, then we have to give say better treatment as far as the wastewater is concerned. Otherwise, there is possibility of contamination even of the vegetables or fruits. So, that way depending upon the purpose of irrigation, we can give appropriate treatments. So, agriculture, landscape, public parks, golf course irrigation, cooling water for power plants and oil refineries, then processing water for mills, plants, then the recycled water can be used for toilet flushing, then we can use the recycled water for dust control, construction activities, concrete mixing, then we can have artificial lakes by using the recycled water. And then say, as I mentioned, if we are going to use for potable purpose, we have to give appropriate treatment to the wastewater. So say nowadays in some of the arid and semi-arid regions, the recycled water is used to recharge groundwater aquifers and then augmenting surface water reservoirs. But this is after going through a series of treatment to the wastewater, so that a good quality recycled water is obtained, and that can be used for say even to recharge groundwater aquifers or augment the surface water reservoirs. So that way, when we look into the recycling processes, so as I mentioned, we have to see say the grade of the wastewater, and then we have to see what kind of treatments we have to give, and then what is our intended purpose of the recycled water. So now within this perspective, let us look what are the important benefits as far as water recycling is concerned. So some of the important benefits I have listed here. So like reduction of treated wastewater discharge to sensitive or impaired surface waters, then reduction of imported water and avoided costs associated with importing water. So we can say recycle the water, give appropriate treatment, so that we do not have to import water for various purposes. Then environmental benefits, so that way we can see that when we are not using the fresh water, we are giving appropriate treatment to the wastewater, and then we are reusing it. So that way we can see that we can achieve sustainable water resource management as far as the environment is concerned. Then recycled water can also be used to create or enhance wetlands and riparian habitats. So we can have say use this wastewater, treated recycled wastewater, say especially to recycled water to wetlands. We can discharge to wetlands, and then that can be say some way of cleaning process will be taking place within the wetlands itself. Then conservation of other resources besides water, like say we can remove chromium from the leather industry, then reuse at little extra cost. So only some, say depending upon the use, say for example the water which we are going to use for flushing in domestic sector, or the water we are using for cooling purposes. So we do not need a very high quality water. So that way with some minimum treatments we can use the water again. So that way we can reuse at little extra cost. Then savings on water abstraction cost. So say if we can reuse the wastewater or the recycled water, then we can see that instead of pumping water from the deeper aquifer systems, so we can save cost of abstraction, or the cost of the power cost we can reduce. So then reduce dependence of vagaries of river flows, then gaining tax advantages in arid and designated zones, then reduction in effluent discharge volume. So when we are when we are treating the wastewater, and then when we are using the recycled water, actually we are reducing the volume of the wastewater. So that way say before discharging this effluent to the river or a lake, so then we don't have to we will not have much volume that we have to give appropriate treatment. So that way we can reduce the effluent that which is to be discharged say to rivers, lakes, or the sea. So these are some of the important benefits as far as water recycling is concerned. So now say within this perspective, so we were discussing about what is say water recycling, and then how we have to do this, and then what are its benefits like that. So now when we look into overall water management solutions, say within a watershed or within a particular area or within an urban environment is concerned, say we can go for various solutions. So, here let us discuss say what are the possible solutions. So, water management solutions. So, as I mentioned earlier, so we have got water stress, so that we can indicate in terms of water stress index. So, actually this is an annual renewable water resource per capita that are available to meet needs for domestic, industrial, agriculture and other purposes. So, say we can come up with an index called water stress index for the particular area based upon the availability of water, based upon the various uses. So, depending upon the supply and demand, we can come up with a water stress index. So, this is one of the commonly used approach to evaluate water availability. So, as we were discussing earlier also, about 2/3 of the world population will be under moderate to high water stress according to the projection that to predict in 2025, and then 50% of the population will face constraints as far as water supply is concerned. So, that way this water recycling is say one important solution that we can look into. So, when we look into water management solutions, say within the perspective water stress index, we can have say we can go for water management solutions are concerned, we can go for surface water management solutions, drainage and wastewater management solutions, polluted water management, and water recycling management. So, like that we can classify into 4 as far as water management solutions as far as a particular watershed or particular area is concerned. So, now if you look into surface water management solutions, so that what we are trying to do is say with respect to the available surface water, say in terms of say water available in a particular area or particular watershed or particular urban area, say in terms of water available in lakes, rivers or the ponds or whatever surface water available. So, we have to give appropriate treatment say and then use so for the we go for beneficial use. So, that way some of the things what are generally used to give appropriate treatment for surface water include modular water storage units, permeable geotextiles, silt traps, vortex flow controls. So, modular water storage units means say we can have systems like polystone from polypipe, lightweight cells with a high void ratio. So, applications include rainwater soakways or stormwater attenuation. So, this we can say we can give appropriate treatment for rainwater or the stormwater, and then we can use for various purposes. Then as far as permeable geotextiles are concerned, this is in conjunction with modular storage units, say just like rainwater soakways, then tape and wrap package for self installation for low risk areas like that. And then third one is especially used for stormwater system, silt traps. So, here we intercept the silt and the small objects from water drainage systems then situated upstream of the modular water storage units. So, that is say how we can use silt traps. Then vortex flow controls. So, this is used with the stormwater attenuation system to ensure to ensure optimum designated water flow rates at discharge outlet by utilizing an internal vortex makes them more efficient. So, like that same available say from rainwater or stormwater as a surface water source, we can give appropriate treatments and that recycled water we can use for the say particular use like either domestic or the agricultural or other industrial purposes. Then now second one is drainage and wastewater management. So, here say the water say which we are draining that we are trying to use effectively. So, we can have pumping stations say for example, for small applications like packaged tank and pump systems designed to lift small quantities of wastewater to reach existing drain or sewer. Then we can have pumping stations say for example, for large applications like a packaged chamber and pump systems to lift large quantities of wastewater to reach existing drain or sewer. Then sewage treatment plants like designed for use where septic tank is either impractical and a connection to the main sewer is impossible. Then we can have systems like grease traps and separators were primarily used in catering and commercial premises, then to prevent vast amounts of grease, animal fats and oils from entering and solidifying in the drainage systems. So, what we are trying to say, these are various systems which we can use say as a drainage water. So, the drained water we can directly say after through this treatment we can use for as a various purposes a recycled water. And then third solution is polluted water management solution. So, here say we can have bypass separators like designed to intercept oil, petrol and silt from lightly contaminated surface water drainage systems, and then like full retention separators say like to intercept oil, petrol, silt from heavily contaminated surface water drainage systems in high risk areas. Then treating the full flow that can be generated from the catchment area through the drainage systems. So, like that what we are trying to, so here say somewhat polluted water, say we give say various type of treatments and then recycle or we are planning to use for particular purpose depending upon the quality of the water. And then finally, say fourth one is the water recycling management solutions. So, this is what is actually we will be discussing in detail. So, here the grey water, this is actually the grey water recovery systems say for domestic or industrial or commercial applications. So, here we can use the recycled water say in combination with the rainwater harvesting say as far as domestic applications are concerned, and then we can capture, treat and store lightly soiled water used within a dwelling in a residential area, or we can reuse the around the house for supplying water to flush toilets, wash clothes or water say the garden. So, like that we can use the grey water recovery systems say for domestic applications. And then next one is grey water recovery systems for industrial and commercial applications. So, here same the recycled water is used in combination with the rainwater harvesting also. We can capture, treat and store lightly soiled water. So, that we can give with some mild treatments we can use for the intended purpose. Then we are reused for supplying water to flush toilets, wash clothes or water fields, then sports grounds or gardens like that. So, that way we can have either the domestic applications, industrial applications and commercial applications. So, only as I mentioned earlier, depending upon the quality of the water, wastewater, we give appropriate treatments and that recycled water is used for either domestic, industrial or commercial or agricultural applications. So, that way when we look into water recycling, say we can say go for say different types of treatments, and then according to the treatments we can use for a particular type of use. So, if we are having the wastewater, so first one is we have to collect the wastewater and then we can give some preliminary treatment like solid waste, floating solids, all these things we can remove. And then next one is primary treatment. So, there say like sedimentation, we can retain the water for some time in say tanks or pits like that, so that the floating materials and other things will be settled down. So, this is so called sedimentation process. So, actually this simple treatment is not sufficient for any kind of reuse. If the water is totally polluted, then we have to go for further treatment. But if it is simple say water coming from a kitchen or like that, then even after primary treatment we can use the recycled water for say gardening or irrigation purpose. Then from the primary treatments the water is going to secondary treatments. So, there we can go for various treatments like biological oxidation or disinfection kind of treatment. So, actually after secondary treatment we can use the recycled water for various purposes like surface irrigation, say for example non-food crop, then say a restricted landscape. So, we can use the water for say to irrigate grass or the landscaping, then it can be put to wetlands where further kinds of treatment will be taking place, and then wildlife habitat, then stream augmentation, then say depending upon the quality of the water we can go for industrial cooling. So, like that. So, this is about the secondary treatment. So, after the secondary treatments the water can be sent to the tertiary or advanced treatments. There we will be giving detailed treatment with respect to the chemical say like chemical coagulation, filtration, disinfection, like that. So, actually the water coming from after this treatment is somewhat pure water to certain extent. So, this water we can use for say landscape, golf course irrigation, then toilet flushing, vehicle washing, food crop irrigation, unrestricted recreation involvement. So, like that we can use this water for various purposes. And then if we are going to use the recycled water for say drinking or potable purposes, then we can say have some more treatment like say reverse osmosis kinds of treatment, or the ultraviolet disinfection treatments. And this water say so directly say using for potable, we can use for groundwater recharge and then surface water reservoir augmentation, like that. So, like this when we are looking to the wastewater say for as far as water recycling is concerned, we have to go through say systematic treatments depending upon the nature of the wastewater and depending upon the use for which we are going to put this recycled water. So, accordingly appropriate treatment will be given and will be reused. So, now further let us discuss somewhat in detail about this various stages of wastewater treatment say for recycling purposes. So, as I mentioned earlier, depending upon the wastewater nature we can give appropriate treatments before recycling. So, first one is the preliminary treatments. So, there say we can remove the heavy solids like wood, rags and grit, etc. So, this we can put the wastewater, we can pass it the water trickling wastewater through a screen with the bars of 20 to 50 apart. So, that all the woods, rags, etc. will be captured. So, that is so called preliminary treatments. Then the water will be sent to primary treatments. So, here we will slow the wastewater the flow rate, and settlement chambers or sedimentation tanks we can use. So, in domestic situation septic tank can be used as a settlement chamber, then which may remove about 30 to 50% of the BOD and suspended solid. So, primary treatment to certain extent we can remove say most of the floating materials, sediments and all those kinds of things, and even some of the BOD also we can remove through primary treatment. Then next one is the secondary treatment. So, here we can go for various kinds of treatments like biological treatment, say for example to remove the microorganisms and remove the remaining BOD and suspended solids. So, here during later stages of secondary treatment the nitrification processes like an ammonia present in wastewater is transformed into nitrate. So, like that we can go for a series of secondary treatments. And as we have seen in the previous slide, this after secondary treatments the water may be used for purposes like irrigation or say golf course irrigation or landscaping like that. Then tertiary treatment is actually this involves taking the wastewater through a further biological, physical or chemical step. So, here further we try to remove the BOD, suspended solids, nitrogen, phosphorus and pathogens in the tertiary treatment. So, we can also provide say like natural systems like wetlands or ponds and lagoons and then where say if land is available, so that will be say the water will be detained for long time, and then either aerobic or anaerobic kinds of say treatment will be taking place in these kinds of systems. So, that is about the tertiary treatments. So, when we look into tertiary treatment, actually say when we look into the wastewater, so the tertiary after the tertiary treatment, the water can be used for various purposes, say reuse is concerned, or recycle after the recycling through the tertiary treatment we can directly utilize like for irrigation, then say toilet flushing or direct industrial purpose like that. So, tertiary treatment for industrial reuse is usually done by using mechanized or physico-chemical processes, such as some of the important tertiary treatments I have listed here, like activated carbon treatment. So, we can pass the secondary treated wastewater through activated carbon, so that most of the contaminants will be removed. Then chemical oxidation and other advanced oxidation processes, then multimedia filtration, then softening like lime soda, adding lime soda or passing through zeolite. So, this is actually mainly for industrial purpose. Then demineralization, say like ion exchange processes, then disinfection like by adding chlorine, hypochlorine, ozone or ultraviolet systems, or then we can put the wastewater through for membrane processes like microfiltration, ultrafiltration, and then the latest is the reverse osmosis. So, depending upon the type of use, so we can choose particular type of tertiary treatment, and then directly from that treatment we can use the water, or we can recycle the water. So, that way when we look into the tertiary treatments, so we can classify the treatment method into the biological methods and physico-chemical method. As far as physico-chemical method is concerned, like screen, grit removal, sedimentation, filtration, etc. So, these are all physico-chemical methods. Then biological method is concerned, we can consider the treatment within the presence of oxygen, or so called aerobic methods, and then anaerobic methods, so say without oxygen. And so, that way some of the anaerobic methods include contact beds, sludge digesters, etc. Then aerobic methods, say we can again classify into suspended growth or attached growth. So, suspended growth say systems like activated sludges, aerated lagoons, etc. we can utilize. Then the attached growth is concerned, we can go for trickling filter, land treatments, etc. So, when we discuss the tertiary treatment, we have a series of treatment methodologies, number of methodologies are available. So, depending upon the type of wastewater, or depending upon the quality of the components of the wastewater, we choose particular type of treatments, and then that also depends upon the intended reuse. So, what kind of, whether we are going to use the recycled water for say domestic purposes or industrial purposes or agriculture purposes. So, accordingly we can choose particular type of treatment systems, so that say we have to see that the economics also, I mean the benefit cost ratio also we have to see when we say put the wastewater through such treatment. So, now let us look into some of the important methods of treating the wastewater. So, the wastewater treatment is concerned, we can classify into conventional way of treating wastewater, and then modern techniques as far as wastewater treatment is concerned. So, some of the treatment techniques are briefly mentioned here. First one is say cesspools. So, this is mainly we are using for containment, say it is generally decentralized way of treatment. So, a cesspool is a big tank of at least 18 cubic meter size. It has an inlet but no outlet. So, we do not treat wastewater here, but store it until it is removed by a sludge tanker, so that it will be taken for further treatment to some other location. So, it is a temporary storage. So, due to the environmental pollution, especially to groundwater, so it is not preferred in urban environment. So, say we have to we should keep the wastewater in a very good container, otherwise if it is leaked into the soil, then the groundwater will be affected. And then second one is septic tanks. So, actually this is a primary treatment and it can be also decentralized. So, septic tanks have both an inlet and outlet, and this is much smaller and suitable for small scale wastewater treatment, and that can be adopted for domestic say like household purpose or the housing societies or hotels like that. And this provide primary treatment and should be followed by a soak pit or leach field. So, that one more treatment is required. So, septic tank is also a conventional way of treating the wastewater. Then third one is leach fields. Actually this can be secondary or tertiary and dispersal, or it can be also centralized system or decentralized system. So, here it is generally a last stage of a conventional treatment system. So, this is preceded by septic tank, and this combination is often referred to as septic tank system. So, a leach field is a series of perforated pipes surrounded by gravity that run in underground trenches. So, this through this say we get somewhat treated wastewater. And then the next one is waste stabilization ponds. So, this can be all stages possible, like secondary, tertiary, then it can be either centralized system or decentralized system. So, like solar ponds, settlement ponds, lagoons or sewage ponds with a small anaerobic ponds in the beginning, followed by large aerobic ponds. So, the wastewater go through a series of ponds, and then finally we will be getting somewhat treated water. So, this say generally this kinds of stabilization pond we place in tandem with reed beds, so that making system more attractive and large. So, in the one of the limitations, we need large surface area to have these kinds of waste stabilization ponds. Then the other kinds of the conventional treatment include like constructed wetlands. So, this also can be centralized or decentralized systems. So, constructed wetlands, actually this is a human made wetland designed to closely imitate the treatment functions that occur in a natural wetlands. So, just like what is happening within an ecosystem. So, there will be some specific type of plants will be there in the system that absorb many of the contaminants within the wastewater, and then the water will be detained, the wastewater will be detained for some time, and that will be going through a natural processes. And then this will be operating on in an ambient solar energy and require low external energy input. So, that way the wastewater will be passing through the system for some time, and then we will be getting somewhat treated water. And then other conventional techniques like duckweed ponds. So, this can be also centralized or decentralized system. So, this is some green colored small plants which grows in sewage holding ponds. So, these plants will be absorbing all this some of the waste material within the water, and then that will become a feed for the plants. So, this feed on the organic elements in the wastewater for growth. For the treatment of low strength community wastewater, this can be used, and duckweeds help in removing nutrients and heavy metals by absorbing components like nitrogen, phosphorus, sulfur, and trace elements like that. So, this is another conventional treatment technique as far as water recycling is concerned. Then another one is so called trickling filter. So, this is actually used for secondary or tertiary treatment. So, trickling filters are always preceded by a primary settlement storage, usually a septic tank, and followed by a humus tank, and they are also known as percolating filters, biological filter, and filter beds. Then a trickling filter is a container usually filled with blast furnace clinker or stones called as media, and then the wastewater will be passing through that, and then many of the waste material will be absorbed. Sewage is distributed over the surface of the media and drains freely to the base. The method is relatively robust, tolerant of peak loadings and does not require power if a fall is available. So, that way this trickling filter is one of the best conventional way of treating the wastewater, and that treated wastewater can be recycled or can be used as a recycled water for say various purposes like agriculture. Then say let us now look into some of the modern techniques used for treating the wastewater. So, this is mainly say we use say as tertiary treatments. So, first one is the upflow anaerobic sludge blanket reactor or UASBR. So, here treatment plants say we can say actually as module it will be available, and directly it can be obtained from the shops and can be assembled. A sludge blanket cultured in the lower portion of the UASBR very effectively traps suspended and dissolved organic matter. Then we can have rotating biodisc contactor, say second unit in the series, and takes the atmospheric oxygen, and then an attached growth anoxic reactor is built into the upper portion of the UASBR for conversion of nitrates and nitrates into nitrogen gas. And then entire operation is simple, and system once stabilized can be left to itself without much human intervention. So, once it is stabilized, we have to only pass the wastewater through the system, and then the system will be keep on working. So, treated water may be used in say it will be somewhat good quality say water. So, that can be used for irrigation purpose depending upon the nature of the wastewater. So, that is about the UASBR. Then another one is another modern technique is called cyclic activated sludge process or CTEC. So, here say the cyclic activated wastewater treatment process, actually we pass through the water through activated carbon. So, carbon oxidation, nitrification, denitrification, biophosphorus removal, all are carried out simultaneously as far as the CTEC is concerned. And this technique ensures that all the effluent process like equalization, aeration, settling and decanting carried out in a single tank. So, this is a very systematic modern system. So, where we can directly get a better quality water, and then this treats the effluent to a level specified by authorities for irrigation or discharge into open water sources like rivers. So, through the cyclic activated carbon process we can achieve say the BOD can be less than 30 milligram per liter, COD can be less than 150 milligram per liter, and ammonium nitrate can be less than 5 milligram per liter, like that. So, like that we can achieve say better quality water through when the wastewater is going through the CTEC technique. So, the technology is automatic and found to be very economical. So, for small scale industries this technique is very useful for the treatment of the wastewater. So, that way we can see that say this either CTEC or the UASBR. So, like that this kinds of modern techniques are very effective, and then it occupies much smaller space, and then for a small industrial unit in an area we can directly they can buy it and put it in operation mode. And then as far as the modern techniques are concerned, the most important technique is so called membrane processes. So, here we will be passing the wastewater through the membranes, and then that will be capturing most of the contaminants within the wastewater, so that we will get a better quality water. So, the membrane process, actually the membranes are semi permeable material designed to separate particulate, colloidal and dissolved substances from liquid solutes or the wastewater. Then these membranes allows substances smaller than the membranes supposed to flow through, while holding back substances larger than the pores. So, depending upon the requirement we can have say microfilters or nanofilters, like that. So, membranes produced from a variety of materials we can use for such purposes like cellulose, acetate, then polyamides, then polysulfones, and then polypropylene, nylon, polyvinyl alcohol, etc. So, various kinds of membranes are available nowadays in market. So the four most common configurations are like we can keep the configuration tubular form, plate and frame, spiral wound and hollow fiber. So like that, depending upon what kind of design we are doing as far as the membrane process are concerned, and depending upon the type of membrane we can have the particular system. So as far as the membrane process are concerned, actually we can classify this into four categories. First one is the microfiltration. So this categorization is according to the size of the membrane. So microfiltration membranes, so actually pores will be greater than 50 nanometers are the least expensive membranes, and this we can use in wastewater treatment for turbidity, removal of solids, separation after biological treatments, and then this also we can use in membrane bioreactors, and this can be used for removal of helminth, ova, other organisms etc. from the wastewater. So microfiltration, when the pores, the membrane pores are greater than 50 nanometer. So that kind of membrane when we use, that is called microfiltration. Second one is so called ultrafiltration. So ultrafiltration means the ultrafiltration membranes, the pore size will be varying from 2 to 50 nanomicrons or nanometer. 50 nanometers have been used in wastewater treatment for many of the same applications as microfilter membranes, except that ultrafiltration systems will give a better separation of finer colloids, bacteria, virus, etc. So when the wastewater is passed through the ultrafiltration system, so other than the colloids and the sediments, all these things, we can also remove the bacteria, viruses, etc. from the wastewater. So this water available from the ultrafiltration will be much better than what is from the microfiltration. And the third system is so called nanofiltration. So here in nanofiltration membranes, the pores should be less than 2 nanometers. So the pressures vary between 520 to 1400 kilopascal, and flux rates vary from 200 to 800 liters per meter square per day. And this the water passing through the nanofiltration we can directly use for even for potable purposes like recharging or other kinds of purposes. Then the ultimate say filter technique is by using the technique is called a reverse osmosis. So here the membranes pores will be much smaller than 2 nanometer and have the lowest molecular weight cutoff, and then high operating pressures of more than 1400 kilopascal, and flux rates vary from 300 to 500 liters per meter square per day. So this is say actually even we are reverse osmosis is one of the commonly used technique, say as far as the desalination plants are concerned. And the reverse osmosis in further treating pre-treated say from microfiltration or ultrafiltration to produce waters of high quality for indirect reuse applications. So even say for example, if the water is not available in particular area, we can the water passing through reverse osmosis systems we can directly even utilize, or we can use for the recharge to the aquifer systems like that. And then one more say modern technique is like ultraviolet disinfection. So where we can remove all the pathogens, bacteria, viruses, etc. from the recycled water, and then directly we can use for the intended use. So like this we can see that say depending upon the use what we are considering, so depending upon the quality of the wastewater, we go for a particular type of say treatments, and then we can directly say use for the intended use depending upon the treatments given. So before closing today's lecture, let us have an overview of the water recycling practices. So water recycling is a growing practice in many regions of the world, including USA, Europe, India, Australia, Israel, etc. So especially in countries like Israel, Australia, where water scarcity is there, this water recycling is very common in many of the areas. Say as far as US is concerned, about 13 million meter cube per day is recycled and reused. and a small fraction of total volume wastewater generated. Actually, this is a small fraction. Out of the 140 million meter cube per day, only about 10% of wastewater is recycled, and suggesting the potential of recycling. And recycled water use on a volume basis is growing at an estimated 15% per year in the United States. And all evidences suggest that water recycling will play a major role in the water management in the 21st century. So, this water recycling practices are increasing in many of their, especially industries concerned. They are looking for zero liquid discharge, that means no waste water from the system. So, that way say many of the industries are now adopting the water recycling. In the United States, for example, at a compound annual growth rate of 15%, the volume of recycled water would be about 45 to 50 million meter cube per day in another 5 to 10 years. So, like that the system is growing and water recycling is becoming very common. As far as water recycling in India is concerned, say in India not much recycling is done, but now industries are picking, especially industrial sector, the recycling is coming up like anything. So, in India some of the methodologies adopted as far as recycling is concerned, water recycling is concerned, like plain water conservation, reuse without any treatments, reuse after treatment using on-site toilet waters and some easily treated industrial waste waters, then reuse after treatment using off-site sources of municipal wastewater. Then say a study of the reuse of wastewater in India shows that the reuse has achieved in affordable cost, and some industries have in fact saved money by reusing their wastewater. So, many examples are there, say where their money is whatever the money invested say in wastewater treatment or water recycling, they have got back in few years time, and then they are saving money as far as water recycling and reuse is concerned. So, in India the water recycling has first begun say in Mumbai, say in 1964 and 65, especially by textile industry. At that time water availability was much less to Mumbai region. So, that way the textile industry started this, showing that about 15-20% of the water can be recycled without any pre-treatment, especially in textile industries, and cost of providing direct reuse was relatively small. Then cost benefit ratio is high and cost recovery periods is say within 2 or 3 years. Then the recycling was carried out in as many as 22 mills in 70s and 80s in Mumbai, and later a few more industries started recycling. A typical treatment scheme, say for example, say if you consider toilet water is as follows: the wastewater. So, first will be screened, then extended aeration will be given, chemical dosing plus flocculation will be done, then sand filtration, then zeolite softening plus acid correction, occasional chlorine shock dose, then makeup water, say for example using for cooling towers. So, then remaining sludge and other wastewater will be returned to sewer line. So, like that it will be going through a systematic process depending upon the wastewater and then depending upon the intended use. So, now before closing today's lecture, let us discuss two small cases where the water recycling is practiced for last few years in Mumbai. Say for example, first industry is Oswald Agro Union Carbide Plant, Chembur, Mumbai. So, here they have given tertiary treatments. This is built up, this is actually a very old plant, say about say 40 years of say actually this plant is there. So, for sewage treatment reclamation with a capacity 5 to 10 million liters per day, raw sewage was obtained from municipal corporation as far as this industry is concerned. And so, being using the wastewater from municipal corporation, which is a dependable source of water, treated water used for cooling, say used for cooling purposes, and treatment scheme include say the wastewater coming from the municipal or the sewage water, then it will be passing through screening, then grit removal will be done, then extended aeration is given, then chemical dosing plus flocculation, so that all the sediment or the suspended solids will be removed, then sand filtration is given, then zeolite, it will be passed through zeolite, so that softening is done, and plus acid correction and occasional chlorine shock doses are given, and then this water is directly used for cooling purposes. Then another example is the Rashtriya Chemical Fertilizers RCF Chembur, Mumbai. So, actually this plant was installed in 2000 for recycling about 23 million liters per day, and the investment was about 400 million rupees. And a complicated treatment process including reverse osmosis is installed in the RCF plant. In 2005, the operating cost was about rupees 39 per meter cube. With the success of recycling scheme, municipality also started to charge this wastewater. So, the wastewater the RCF was taken from the municipal supply. The plant in the RCF has the following flow sheet, like wastewater will be taken from municipal supply, waste to sewage, then it will be put through screening, then grit removal, then activated sludge system, clarifier, then sand filter, then pressure filter, then cartridge filter, then it will be passed through reverse osmosis, and then degasser to remove carbon dioxide, and finally this is used in industry. So, that way RCF this last say 10-15 years they are very effectively using this municipal sewage water waste water or the sewage for their water supply in the RCF plant. So, now before closing the lecture, let us look at the future of water recycling. So, water recycling has proven to be effective and successful in creating new and reliable water supply. Then non-potable reuse is widely accepted. Then advances in wastewater treatment technology and health studies say maybe for potable purpose also we can use. Recycling waste and grey water requires less energy than treating salt water like a desalination system. And water recycling is a sustainable approach and can be cost effective in the long term. Then public be informed and involved in the planning processes. So, before closing today's lecture, so these are some of the references used for today's lecture. Then few questions, tutorial questions, critically analyze and study the scope of water recycling in India, whether water recycling and reuse a solution for water scarcity in India, study and compare various case studies available and evaluate the economics. Then self evaluation questions, illustrate water recycling and its importance. What are the benefits of water recycling and what are the different stages of wastewater treatment? Illustrate various conventional ways of treating the wastewater. Then a few assignment questions like discuss various uses of recycled water, describe various water management solutions, describe the various stages of tertiary treatment methods, illustrate various modern ways of treating wastewater. So, today we are discussing about the water recycling. So, we are discussing about the how we can use the wastewater for various purposes by giving appropriate treatments depending upon the wastewater nature of the wastewater. We have to give appropriate treatments for the intended use. So, in the last lecture, in the next lecture we will be discussing about the water reuse and further reclamation and further topics in this module. Thank you.